while sharing the screen, what I would like to do is that we have to go for the new topic today. And the idea of this topic is to come to the point where we have left. So the point is that we have to make it clear that what type of the things which we are doing right now and how these things will be beneficial for us. The main thing which we would like to discuss is that can we understand the experimental techniques in physics in a better way, and what are the different terms which we have to use to understand this thing. And I would say that overall, if you look into the details of the things which we are doing right now, main points are in the first section you would have many things which are related to the scanning electron microscope, and in the second thing, in the second unit, you would have this the thing which you would like to come across is the FTIR and XRD. So main components are again the electron diffraction, which we have done in the lead and RHEED. And after that, we would like to come to this new topic, which is the FTIR. Okay, so let's name it. So it is Fourier transform infrared spectroscopy. This is the thing which we are coming across, and if you would like to have the knowledge of this FTIR, so in short we will write it as FTIR. Okay, so Fourier transform infrared spectroscopy. Let me make it a bit bigger. So let's again second point here, and I would like to erase the top one. Okay. So in the case of the Fourier transform infrared spectroscopy, what happens that we have to discuss in detail. First of all, again, it is the characterization techniques and the students, what they do, that they look at their samples with the help of the FTIR and X-ray diffraction and the transmission electron microscopy. So the idea is that there are the things which we have discussed, like you have if you have prepared a sample, in that case, what you are trying to do, let's say that when you have prepared your sample, in that case, what you are trying to do, first of all, you are doing the simplest thing which you have. Look at the sample with the help of the optical microscope. Okay, so optical microscope, with the help of the optical microscope, you can look at the sample. First of all, that if there is no information, then we have to go for the XRD, which is cheaper over there. And the third thing which we would like to do is SEM, or oblique TEM of the sample, when you are trying to do the characterization of these samples. Fourth thing, most of the times what you do that before doing anything, even the fourth thing which I have done here, okay, that sometimes people do that the first thing. After fabrication of the sample, they can directly come to the first point, that is UV visible. Okay? UV visible. Okay? And the fifth thing, many people don't do that. Okay, then they will come to the FTIR. Okay? FTIR. So what will happen in this case? We have to understand from one or other point that here we are going to talk about this FTIR. So our main focus here would be to talk about this topic, which is FTIR. So in case of the FTIR, if you look into the sample, then you are trying to excite the vibrational and rotational states of the material. So for example, if you have the absorption range in the visible, in that case you will do UV visible. But sometimes what will happen in case of the molecules or some other materials, their vibration and the rotation levels, they can be excited with the help of the infrared spectroscopy. What we do that in this case, we do this the Fourier transform infrared spectroscopy. Okay? So let's correct it. This one. Okay. So it is transform. Okay? Transform. Okay. So what we are trying to do in this case, that first of all, our idea would be to understand the things which are related to this one. So let's come to the Michaelson interferometer. So first of all, we have to understand what is a Michaelson interferometer. If we would like to understand the Michaelson interferometer. So with the Michaelson interferometer, we can understand in detail that what is the meaning of this, the FTIR in this case. And the basic principle will remain same. So let's draw this information for us. So let us have this information here. So I would like to draw it here. So what do you have here initially? You would have a source of light, and this source of light will give you light, and that will go in this path here. Okay, and here you would have a mirror. Okay, here you would have a mirror, or I can make it a bit better, so that we have plenty of space. So here we have one mirror, and this mirror is fully reflecting mirror. And then what you have done, that here you have a beam splitter at this point. So what you would have, not like that, if I can turn that. So you would have a beam splitter. Let's say somewhere here. And along this direction, you would have, okay, so let's see that somewhere here or here you would have another mirror which is fixed over there. Okay? This is another mirror. So we are seeing that this mirror is a stationary mirror, and this mirror is movable mirror, and this is the point which is O point in this case. What will happen? That ray of light which is there in this case, so you would have like this, and let me make it a bit bigger. Okay, so beam splitter is here, and you have a source at this point, and this is the source. Okay. So again, let me repeat the things which are there. Okay. This is a beam splitter. Okay, BS. What I'm saying, at point O, you would have this beam splitter. What is beam splitter? What is a beam splitter? That you should know that BS is a beam splitter. Beam splitter. So what is main aim of ours in this case? What we would like to say that in the case of the Michaelson interferometer, you have a source which is emitting the monochromatic light in this case, and then you have a beam splitter. Beam splitter is a component which divides the incoming beam into two parts. One is going to be transmitted through the beam splitter, and the second would be reflected back. So sometimes what we say that the contribution of this beam splitter is 50-50 beam splitter. Okay? What does it mean? That 50% of light will be transmitted, and 50% of the light, 50% of the light will be reflected. Okay? So that somehow we define these beam splitters like this. You can have many other beam splitters. They can. So what will happen in this case? You would have this beam is going towards this direction, which is the movable mirror, and this is the stationary mirror in this case. So what is this? This is a stationary mirror. Mirror. Okay, and this one, the second one is the moving mirror in this case. Moving mirror. Okay, so what we mean in this case? So the incident light, this light beam which is incident, that is split into two parts with the help of the beam splitter, which is 50%, which can transmit the 50% of the light to this mirror, movable mirror, or moving mirror, or movable mirror. And the second one is your the this which is the stationary mirror. So your light, the ray of light that will be reflected back from here, and it will come over there. Okay. So what will happen then when these two beams, they are overlapping in this case? So let's say that okay, both of the beams, when they are coming from this point of view, you can have a detector over there. Okay. So what you would have here, you would have a detector. Okay. Here you would have a detector. This is your detector. So what will happen here? Okay, you would have the interference fringes which are there. Okay, so the interference fringes which are generated like this. Okay, and this type of the interference fringes will be there, which will be seen because the light beam which is reflected from M and S, both of them overlap in the beam splitter, and then they will propagate in this direction towards the detector. So what will happen in this case? So you would have the interference pattern which is being detected by the detector. And what you can do that in most of the cases, what will happen? That in some of the labs, you will also see additional beam splitter like this. So let's see this, what I'm doing, that similar kind of beam splitter which you have here like this. So let's, I'm copying this one and pasting. So this one. So what we are doing that we are keeping the same type of the setup here. Okay. What we are going to do, we have similar kind of setup over there. Before putting this one, let me do one thing. Before we put this one, what we will do that let's see that how many times this ray of light is going to traverse through the beam splitter. Okay. So if you look at this detail of this light, what we are trying to do that let's see that first of all, when this ray of light, when it went to the movable mirror, is what will happen? This will go, okay, so it goes through once when it entered from here, and then it is reflected back from here, let's say that what you have done. So you would have this is reflected back in this case, and then So it goes to the detector. So this ray of light has crossed the beam splitter only once. The second case, what will happen, that you see that okay, this ray of light, it goes once, it goes second time, and then it goes third time. It will come back and then it will go to this one. So if you look at the ray number 1 and the ray number 2, so let's say that one is the ray number 1. Let's say that here, let's say that we are saying this is ray number 1. This is ray number 1, which is going to the movable mirror. This is ray number 2, which is coming from the stationary source, this mirror. So when the 1 plus 2, here what will happen, you would have 1 plus 2, okay? The both of the beam will interfere in this. Now, can you tell me that how many times the beam will go to the sample? So let's say that how many times it traverses the sample or the beam splitter. So let's see that, okay, let's count ray number 1 because it started from here, okay? Let's count it. Let's do it like this. Initially, what you would have, that you are trying to come to this point. So when the ray of light which is going toward the movable mirror, I am just counting this one. So now it crossed, when it came from this point, it crossed the beam splitter, okay? That is one time. What I am saying, this is one time when it went through. Let's say that count it 1, okay? When it is going to the mirror M movable, it go over there, it will go over there, it is reflected back, and then it will be going to. So this mirror number, this the beam number 1, the radiation number 1, that is only traversing the beam splitter one time. Okay, is it clear? And the second thing is that about this the ray number 2. So what will happen? Ray number 2 will also come from this and it will traverse once, as it has crossed the beam splitter once, and then it goes in this direction. Okay? So let's see that it goes in this direction. Okay? But it crosses again the beam splitter. Okay, and then it come again when it is reflected back. From here it is reflected back, and it goes in this direction, and again it goes through this one. So one, second was when it went second time, and third time when it came back. So it was the third time. So it is total number of the times when the ray number 2 went through the beam splitter is 3 times. Okay? It is 3 times. Okay, so it is ray number 1. Just a minute. Okay, hold on. We would like to come back to our discussion, and here we have So we have to see here, okay, what we are trying to do, that first of all we have understood that what is the meaning of this Michaelson interferometer, how does it work. I have mainly emphasized that you have a beam splitter, and this beam splitter will divide the incoming ray into two parts, okay, incoming beam into two parts. Okay, so let's see that how does it work in this case. So as far as the discussion of this is concerned, so we have to come across this, that how does it work. We would like to come to this point, what we are talking about. Okay, so this mirror is the movable mirror. Okay? What we can do with this mirror, that this mirror can move. Okay, for example, it can go this side, it can go this side. Okay, we can move this mirror, okay, in order to see the pattern which is there. This mirror which I am talking about, this is the movable mirror. This is the movable mirror. But the second one, when you come across the second one, this one, okay, when you are coming across this one, okay, so this one, in that case, this mirror is the stationary mirror in this case. Okay? So what you are trying to do, this mirror is the stationary mirror. It does not move. So your ray of light which is reflected, that will not be affected by the motion of this stationary mirror in this case, because it does not move. And this is the beam splitter which we are coming across. This is the beam splitter, and here you have, this is the source which we are talking about. Okay? So this, all the information which is there is summarized in this case. What we are trying to do, that let's discuss the rays of light which are reflected from this point and this point. Okay, what we are trying to do right now, if you look into this ray of light which is this one, okay, so let's say that this is one ray of light. If this ray of light has crossed the beam splitter only once, because it came from here and it entered, and then it is reflected back from this surface, okay, from the back of the beam splitter, because it is coated, so it is reflected back, and then they will interfere here. Okay. On the other hand, the beam number 2, that traverses the beam splitter 3 times. Okay. It will go through the beam splitter 3 times. How it goes through 3 times? Okay, let's see that. Okay. We start from here. Okay, this is the beam number beam number 1. Okay, this is the beam number 1. Now what will happen, it goes through the beam splitter. You are seeing that, okay, this is going through the beam splitter. Okay. That's one time it has crossed the beam splitter. Now it is reflected from this point. Okay. It goes to that direction. Okay, up from this direction it will go to up. Okay, what will happen, it will again pass through the beam splitter in this case. Okay, so you just look at that. Okay, it is going through the beam splitter again, and it goes up, and then it will come down. Okay, it will come down reflected from here, and then it again crosses. You see that, okay, from here, at this point, you have again this beam is crossing through this beam splitter. It comes from here and it goes to the beam splitter again. Okay, so this is 3 times it is going to traverse through the uh, through the this beam splitter. In order to compensate that, what you do, that you would have in some of the Michaelson interferometer experiments, you will also see that there are some people, those who are using this the the additional beam splitter which will be there. Okay, so this beam splitter which is there. So let's say that this beam splitter which is there. So what we would like to do with this beam splitter, we would like to put this beam splitter here. What we will do, that we will put this beam splitter here, and then at the position, let's see that it change the story in this case. Let's see that. So I'm putting this here in the path of this beam, which was the beam number 1. Okay, I'm putting this one here, and rest of the things we would have is like this. No, let's So we would like to get rid of this thing, which are the unwanted rays. So now let's see that. Okay. Now what will happen? That we have seen that ray number one. Okay. So what you would have, the beam one, beam two, beam number two. Beam number one is reflected from the movable mirror. Beam number two is reflected from the stationary mirror. So how many times it traverses the beam splitter, goes through the beam splitter, how many times? Beam number one goes only once, okay, one time. What about beam number two? Right before the second beam, okay, it was how many times through the beam splitter? It traverses three times, okay. So what you would like to have, that you want to make the beam number one should also go three times. We would like to have same timing for both of the beams, okay. So it should also three years. So if you introduce this one, the second one, then let's again count the beam number one. This is the beam number one. It goes, so now it goes through the beam splitter, this one, okay, and then it goes through this one. So it was one. Here it crossed once. In the second case, it crossed, it's two. Then it is reflected back. Again, it is reflected back, and then it crosses thrice. Okay. So now the beam number one is also traversing the beam splitter three times. So after the introduction, now the story will change. So what you would have, that in the case of the second one, what you would have, let's say that here the after the compensating plate, again we would have this. So what you would have here, you have two situations, okay. The situation number two is again after 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 introducing compensating plate, compensating plate. So this beam is the compensating plate, and it has same dimensions and as that of beam splitter, and it has same refractive index, same material, same thickness of the material. All the qualities of the beam splitter and the compensating plate both are same. So after the introducing beam splitter, now you have what you have done. You have plus two times, two times, two times. So it will be total three times. So you would have now beam number one and beam number two is they have crossed the beam splitter three times. They have crossed the beam splitter three times. Is it clear for everybody? Okay, let's ask you guys, are you there or not? Yes, no, Okay, can you answer this? Yeah, answer please. Everybody should answer. Yes, please. Again. Yes, 8 students have not replied, please. Yes, please reply. Yes, please. Okay, anyway, I'm going to suspend the poll and let's come. Most of us are saying that repetition will help. Let's have a knowledge of this. Maybe I can draw a bigger one for you guys so that you understand in a better way what is going on. Okay, so let's discuss with the help of this diagram, which is bigger than before. This is the ray of light that is one, okay, which is covered there. Okay, then you would have, or I can just make it. So how it will go? So this is the mirror. Okay, now can you tell me how many times this is the beam splitter? This is the beam splitter. Okay, how many times it has crossed? Okay, this array of light only. So can you tell me how many times? You can also Yeah, you can talk to us directly. I have enabled your voice. It would be better to talk. Who will talk? We have students. Dipti, can you talk to us? Dipti, Diksha Devi, can you talk to us? Diksha, Dinesh Thakur, can you talk to us? Divya Chaudhary, Gaurav, Jasprit Kaur, are you there?
Yes, sir.
So, Jasprit, can you tell us that how many times this ray of light crosses the beam splitter right now? How many times this ray of light crosses the beam splitter? So this, let me explain it.
One time.
This is here, and then now it enters the beam splitter, and then it goes to this mirror, which is the movable mirror. How many times? And then it is reflected back
So
from here.
one time.
One time. You are right. Okay, that's only one time. Okay, got it? That's only one time. Okay, so this is one time now. Okay, but about the second ray of light, so from here it is reflected. No, the second one is reflected from here. Okay, and then it will go to this point. Okay, let's say that here you have a mirror. Okay? Here you have second mirror. Okay? So now about this ray of light, from here we have to count from here when the beam of the light. Okay, so when it entered, it was one. Okay, it was one time. Okay, and now it goes to, it is reflected from this surface, and now it is two. Okay, it goes in this direction, and from here it is reflected back again, it goes through this. Okay, that is the third time. No? So how many times this ray number, this is that this is ray number 2, how many times this crosses the beam splitter? Now just please, are you there?
So three times.
Three times. Okay, it's three times. Okay, the
Okay,
ray
so
number
three
2,
times.
yeah, three times, you are right. Okay, this is the ray number 2 which is coming over there. Okay, so we can give them dash names. Okay, dash, this is ray number 2. So one, ray number 1 that crosses one time, and if you put another beam splitter over there, okay, if you have put another beam splitter over there, then what will happen, it will pass through the beam splitter how many times? Three times. Okay. What will happen here, you would have, when you put this compensating plate into this setup, in that case what will happen, you would have this this is again, so this ray of light, this was crossing, this was only one time. Okay, so if I include another beam splitter over there, then it will go second time into it, going through second time, and then it is reflected back again, it goes through this mirror, this beam splitter, and it is reflected from here. So we both are three times. Okay, after introduction of the compensating plate in this case. So you would have, what you would have, you can put your sample here, you can investigate this sample. Okay, what you can do, that you can put your sample here and you can investigate this sample, in this case sample. Okay, in this case, so what will happen, that you have to move this mirror in such a way that what you have to do, that let me put it out like this. So you would have a graph between this. Okay, and here what you would have, you will come, So like this one. Okay? So you would have here, what you are trying to do, you are trying to move it, let's say that on this position, okay? So these positions, like this position, okay, just a minute, this position, then this position, again you have this position, you are moving your mirror, okay? Okay, but make it sure that they are equally spaced in this case. So what you would have, you are moving it like your, you would have here, so what you would have lambda by 2, okay? So then you would have lambda, okay? Then you would have 3 lambda by 2, okay? And then you would have 2 lambda, okay? Like this one. So what you are trying to do, you are translating this movable mirror into that, you are making translations of lambda by 2, lambda, and 3 lambda by 2. For example, if you have the value of, if you are moving it by lambda by 2, in that case what will happen, this is intensity, and here you would have the retardation. So what is it? It is the retardation. So what you would have in the retardation, you would have delta will be equal to 2 OM. What is this? OS minus OM, okay? Or it is OM minus OS, okay? So what you are trying to do, you are making translation of this mirror. At lambda by 2, you would have the destructive interference, and here you would have at lambda, you would have constructive interference. Here again at 3 by lambda by 2, you would have destructive interference. Where the intensity is minimum, you would have destructive interference. Where the intensity is maximum, you would have constructive interference. So if you look at the details, if the retardation, when you move it, if it is the integral multiple of lambda, in that case you would have constructive maxima. If it is half integral multiple of the lambda by 2, or multiple of lambda by 2, in that case what will happen, it will be destructive interference in that case, okay? So that you would have interference fringes from where we will look at the material in this case, okay? So we would like to continue this in our next lecture. If you have any question, please don't hesitate to ask me. We have started with the Michaelson Interferometer, and basically we are trying to understand the meaning of FTIR, spectrometry. Do not hesitate to ask me any questions. Yes, please. Many students left. Yes, any questions? Don't hesitate to ask me questions. Okay, you can leave the session.
Yes, sir. I have a query.
You have any question, please? Any question, Divya?
Yes,
Very
sir.
good. Yes, very good. Yes.
जब हम वो बीम स्प्लिटर से वो स्प्लिट करके प्लस होती है रे 1 एंड रे 2 डिटेक्टर के पास जाती है तो तब क्या होता है?
Oh, yes. So we would come to the question of. Okay, I'm sharing again the screen. Okay. Yes. So Divya, can you again repeat your question? Yeah, just a minute. So, do you mean that if I understood your question correctly, you mean that when the ray number 1 and 2 they go to the detector, what happens? Is this the question? Okay.
Yes, sir. Yes, sir.
They interfere, the ray number 1 and 2 they interfere in this case, and what they will do, they will give us interferogram, okay? They will give us interferogram. So you would have the fringes like this, no? For example, if you are looking at this, so at the detector they will give us the fringes, and the output of the detector would be like this. So you would have fringes like this, okay, this type of the fringes, and these will be detected. So you would, what the detector will see that as a the response of intensity versus the wave number, okay, wave number which is there, okay. If the light is absorbed, in that case the intensity will be down, okay. If it is destructively interfering, in that case intensity will be down, and in the case if it is going to the maximum value, in that case what will happen, you would have a constructive interference. So answer to your question, Divya, that at the detector will detect the interfering intensity of the two beams. Is it clear?
Okay, sir. Yes, sir. Thank you, sir.
Okay, no problem.